we learn about the steps in quantitative analysis, starting from understanding the problem, doing literature search in standard methods and published methods, and then from there we select which method to be used, and then we go to the sampling area, do sampling according to the nature of the sample, preserve, and then sample prep. Okay, and then after sample preparation, what should be done is that we have to perform analysis with any instrument that you want. Okay, if it's inorganic analytes, then you know it is using spectroscopy method. Okay, if it's organic, it's usually chromatography. Okay, this is in the scope of chemical analysis, specifically quantitative analysis. Okay, so after this, okay, we are going to apply statistic. That's why we need replicates. If you don't have at least 2 data, you cannot get any statistic data. Okay, and then you report. Okay, before this I said that sample preparation is the most laborious step in a chemical analysis. Okay, after that is the analysis. Okay, analysis is relatively straightforward, whereby we already prepare clean sample and then inject, and then we get data. Okay, the question is that what kind of data the instrument will give. Okay, the thing is, instrument will give data in terms of signal. Okay, whereas in report, we want to report data in terms of concentration, right? When you want to do quantitative analysis, you want to report to the court. Okay, we have like 1 milligram per liter of amphetamine inside blood of defendant A, for example. And then we want to know in terms of amount. Will the instrument give concentration and amount straightforward? The answer is not frequently like that. So what does instrument give? Okay, instrument, okay, usually give signals in terms of according to the detector. If let's say you are using spectroscopy, atomic absorption spectroscopy, the signal you will get is millivolt. Okay, this is electrical signal coming out from the instrument. Okay, if you are using chromatography HPLC UV, for example, you will get absorbance. Okay, absorbance. If you are using CE, you will get absorbance units as well. Okay, so it doesn't give you direct concentration result, but we can do something to get concentration result. What should be done is that in order to get these concentration results, we have to do one more step. Okay, what we call as, we have to prepare calibration graphs. Okay, we have to prepare calibration graph based on standard solution that we know each of these concentration. We know this concentration because we prepare them using standard chemicals. Okay, if let's say you want to analyze zinc, then you buy zinc standards from chemical companies. You prepare according to the concentration that you want. So when you have calibration curve, okay, so calibration curve, just imagine this is 1 ppm, 2 ppm, 3, 4, 5. Okay, so 1 ppm will give 1 ppm over here will give signal of 1. For example, this is absorbance. This is using UV visible spectroscopy, for example. And then 2 ppm. 2 ppm will give 2, 3 ppm will give 3 signal. And then you can get a linear graph. Means that the instrument is true okay, in analyzing concentration from 1 ppm to 6 ppm. These are all standard solution. Okay, so where is the sample? Okay, the sample is that when you run another volumetric flask, okay, another volumetric flask labeled as X, you know is zinc inside, for example. Okay, you run, and then the sample will give you, for example, reading of adsorbent 3, for example, or 2.5. Then you know, okay, at 2.5 the concentration is 2.5 ppm. So this is X is 2.5 ppm. Okay, means that doing standard solutions, doing calibration curve are really important in any chemical analysis quantitatively. Okay, so the answer you will get 2.5 ppm. Now you know the concentration, okay, based on the signal of standards and your sample. That's what we call the data for concentration. Okay, before we go into type of calibration curve, we have to understand first jargons and also commonly used units, so that we can start the discussion from the beginning until the end. So the commonly used concentration is molarity. Molarity, whereby it equals to the number of moles of solute per liter of solution. So we have mole per liter. How we can get mole? Okay, I hope chemistry background students or forensic science background student will understand how to do this. If you don't know how to get number of mole, it's easy. You just go to periodic table and take the molecular weight. So you can get the mole from the molecular weight, okay, then directly get moles. Okay, so this is commonly used in R&D labs or sometimes in any QC/QA line of work. Okay, what if you don't want to go to the hassle of finding this molecular weight? You can do part per million as your unit. Okay. Wait. Part per million, whereby it's supposed to be here, liters of solution. Liters of solution. Okay. You see, liters of solution is still the same, but this time you are using the mass. The mass of your analyte. Okay. Means that you weigh the chemical, provided that is a single speed is the element that you want. Okay, if it's in salt, then you have to calculate using molarity, because when you weigh, for example, sodium chloride, you are weighing the whole sodium chloride, whereas you want to only have sodium. Okay, if it's 1:1 ratio, it's okay like this. So 1 sodium, 1 chloride. But if you do, for example, disodium phosphate, okay, disodium phosphate, Na2PO4, means that there are 2 sodium and 1 phosphate. So to use part per million, you can do that, but you have to take into account the number of mole. Okay. Another one is that part per million is meaning that how many milligram in 1 liter of solution. That means like in a very big solution, how many milligram available. Another unit that is more in trace level, means that it's really small, is part per billion. Okay, is meaning that it's microgram of solute in liters of solution. Okay. Most of the time, these two are used in any lab that do routine monitoring. Okay, now we go into example of how to calculate molarity. Just to be quick one. Okay, molarity is mole per liter. okay, you want to, what is the molarity of salt? Okay, solution when 0.6 gram sodium chloride was dissolved in 100 ml of water. Okay, so you take the 0.60 gram times the molecular weight. Sorry, divide by molecular weight because it's the other way around, kan? Molecular weight is gram per mole, but mole is on the nominator and the gram is down there. So this is actually division. Okay, and divide by the 1 liter. How many ml in 1 liter? So you can get 0.1 mole per liter in this sodium chloride solution. Okay. Okay. And then what if you want to use the milligram per gram? Okay. So we have two. Okay. Milligram per gram is usually for minerals, solid in solid. Okay. This is not used a lot because remember in quantitative chemical analysis, we are doing analysis on solution. Okay, later we will go on that, but I will show you if you have solid in solid. ppm means that there's 1 unit of mass in million matrix. Okay, so gram of solute over gram, 1 million gram. Okay, but in chemical analysis, we don't usually work with grams. We usually work with milligram. Okay, you can get this is you can take this 0.6 bawa naik atas, bring up, and then you can get 0.10 to the negative 6. Okay, power of 6. Then you can get microgram over here because of this one. So leaving only gram on the nominator. Okay, to be simply or milligram per kilo. This is simply the apa panggil? The tukaran unit, the change of unit only. Okay, ppm is equal to microgram per gram or milligram per gram if you are doing in solid. Okay, but what if you want to do in solution? Okay, you can use this ppm in solution if you are working with solid dissolved in water, what we call as aqueous, any aqueous solution. Can we use milligram? Can we use ppm if you dissolve 100% in methanol? The answer is cannot, because for 1 kilo of water is equivalent to 1 liter 1 liter, because the density is almost 1, kan? So that's why it is only applicable for aqueous based solution. Okay, the same thing. Okay, you can get microgram per mil, okay, or milligram per liter. Okay, milligram per liter. It's easy to use the milligram per liter. Then how do you prepare the set of solution after you understand the unit and everything? How do you prepare? Okay, the first thing is that you want to have volumetric flask. Okay, after you calculate, okay, I should take 0.6 gram of sodium chloride and put it inside 100 ml. Okay, sounds easy, but calculation must be correct, weighing must be correct. It must be 0.6000 gram for decimal places using analytical balance. Okay, and then you dissolve. Okay, if it's sodium chloride, it's easily dissolved. But what if you have like sodium phosphate, or if you have any drugs that are not that dissolved inside solution? You can use a percentage of organic solvent. When I say percentage, as low as 5% methanol sometimes can do the work on dissolving. Okay, but can you still use the ppm? Yes, you can still use, because it's 95% of water. Okay, you only need 5% of methanol to dissolve a bit, and then you transfer into volumetric flask according to the volume that you want.